I had to stay at school, so I
You had
changed
your
the
school
class.
yesterday.
Yes, ma'am.
Why?
Ma'am, there was a program, that's why.
Okay, all right. Function was there.
Yes, ma'am.
Farewell, your farewell.
No, ma'am, for Onam.
Okay, okay. All right. But so late? I think it was on the
No, ma'am, it
last.
was 3:30. It was 3:30 in the afternoon.
Okay, all right. So see, so now tomorrow we'll have our class, no? Instead of Friday.
Yes, ma'am.
Okay. So I discussed with you few things. Could you revise this chapter because this is coming in your exam?
Yes, ma'am, I revised
Are you
somewhat.
able to understand reflection part? Have you understood properly?
Yes, ma'am.
Your exam is on 7th October. Now, I want to complete this chapter. Is it? This is 12th. This is 13th today.
Mm,
Yeah.
mm,
So, I think we'll be able to cover it. I just want to take one class where we could just practice questions and practice the things. So, for that, we should cover
okay,
everything
ma'am.
for time. Anyways, I discussed with you the concept of total internal reflection, the phenomena in which a ray of light traveling at an angle of incidence greater than the critical angle. Critical angle is the angle for which the angle of refraction in the rarer medium is 90 degrees. That's what we have discussed. Now, Snell's law's application is the most important question. Now, this first question we could just discuss, and second one is left. Yeah. See, here light ray, this is a question I think from your NCERT. It's a very common question. The light ray enters at the surface, it gets refracted because of the bending. Okay, so light ray comes here at the surface, it gets bent here, and then see here it says we have to finally calculate this value of angle R. That's what we have to do. Now we have to calculate the critical angle. Okay. See, what happens is if you see this arrow, basically this comes like this ray of light, this gets refracted, and then it grazes the surface like this. If it is grazing, definitely this means here there is this angle must be the critical angle. That's why only
Mm,
this has happened. So we can say, like, if I just extend it, this definitely has to be the critical angle. Let's say this is 90 degree, this will be the critical angle. The reason, otherwise, if this was not a critical angle, the light ray should have been refracted because this is again back to the medium air. If this is here, this is back to the medium air.
mm,
Okay. So, see, here if I apply Snell's law, let's say this is A, this side is B. Okay. Let me apply Snell's law over this surface at this point. BC surface means this. So let's say the refractive index is something n into sine IC is equal to 1 into sine R. For air, we take the refractive index as 1. So n into sine IC is equal to 1 into sine R. So basically from here, we can say a sine R is what? 90 degree because TIR has occurred here. So we can simply say sine IC is equal to 1 by n from here. Am I clear?
yes, ma'am.
Okay. One more thing here, the angle of incidence that is given, this is already 70 degree. Okay. This 70 degree is what? This is the angle of incidence. This is the main actual angle of incidence. This is the refraction. So this is also known to us. We can utilize it anywhere or wherever we need it. Okay. Now coming to this surface AB. Like there is a change of the medium here, this surface glass to air or whatever is the surface because it has not been mentioned. Similarly, here also from air to this surface, the light ray is entering. It
Yes,
is.
ma'am.
So
Yes,
here also
ma'am.
we can apply Snell's law. Now you tell me, Basmi, how to apply the Snell's law.
Sine IC by wasn't
At
sine
this
R.
point, maybe this point.
Okay. Sine 70
Hmm.
by sine R is equal to
Tell me in this method. In this form, your answers won't be incorrect. Refractive index of air. What is the refractive index of air?
air is 1.
1.
1.
Now say then 1 into
1 into sine 70 No,
Correct?
no, 1 into.
Correct.
Alright.
Same refractive index, same angle. Okay, same side, yes. Then,
Okay, ma'am. It's equal to uh, sine R
correct,
into.
into n. The medium's refractive index here is n.
Yeah, into N.
This is how you apply the Snell's law. Take that refractive index, multiply to the angle is equal to, then you
Okay.
multiply refractive index and then to the angle. So this is at point 8. So this is what, as you told me, 1 into sine 70 is equal to n into sine r, right? So from here,
Yes,
we
ma'am.
say this is sine r's value can be equal to the sine 70 degree divided by n, which is sine 70 is already given in the question, 0.9397. This is 0.9397 by n. These are the two conclusions that we can say from both the points, BC also and AB also. Fine.
Yes, ma'am.
Let's say this is M, this is N, this is P, this one. So in this triangle, all of these, as I discussed, I think I haven't discussed, but see all of these, this R, this 90 degree, this IC. This is forming a complete triangle. So their sum will be 180 degree.
Yes, ma'am.
All right. So I can say R plus 90 plus IC is equal to 180 degree. So from here, see R plus IC will be equal to 180 minus 90. That is
Mm.
90. R plus IC is 90. So what is angle R? 90 minus IC? Can we say
Yes,
that?
ma'am.
90 minus IC, right? Now see,
Yes, ma'am.
what was your sine R? 0.9397 by n. We have got the value of
Mm.
this R. What is the value of this R? Can we write R as 90 minus IC?
Yes, ma'am.
So I'll get this sine 90 minus IC is equal to 0.9397 by n. Basically putting, if I put this value of R over here, right? This is how we'll get.
Yes, ma'am.
Sine 90 minus theta is cos theta.
Mm.
I can say cos theta is equal to 0.9397 by n. Do you agree till here?
Yes, ma'am.
This is cos IC. Now look, cos, if this identity you must be knowing, cos square theta plus sine square theta is equal to 1. Is it?
Mm.
Now the angle is IC. So cos IC square plus sine IC square is equal to 1. Right?
Mm.
From here,
Yes,
we
ma'am.
sine square IC is equal to 1 minus cos square IC. Now sine square IC. What is sine IC? Initially we calculated. Sine IC is 1 by n. Yeah?
Yes, ma'am.
So I can say, see, sine of IC is 1 by n. So sine square IC will be 1 by n square. So 1 by n square is equal to 1 minus cos square IC. Right? Should it be like
Yes,
this?
ma'am.
I've just
Yes,
put in
ma'am.
its value. See, we have to calculate this critical angle. N is our refractive index. So from here, sine R has been done. What did we do? I'm just telling you. At this point P, we calculated the value of sine IC. We got it. We just kept it aside because it wasn't used at that time. Here we just applied the TIR and Snell's law. Here at this point M, this one, this at the AB side, we again applied this Snell's law. What we got? Sine R's value. Then from the triangle, we could get the R's value, that is 90 minus IC. When we put it here, we got sine 90 minus theta, which could possibly give us cos theta. From cos theta, we got the value of sine IC, which we already kept it separate initially. So sine square
Mm.
IC is 1 by n square. This is what we get. So from here, if I say cos square IC, what is the value of cos square? Basically, I have equated both of these here. From here, sine square IC, this is under root minus cos square. Or one more thing we can Let me just write it again. See which step. Cos IC's value we've already kept. Here. 0.9397
Yes,
by
ma'am.
n. We did it. So cos square IC means 1 minus n square is equal to 1 minus cos IC is equal to 0.9397 by n. So cos square IC will be square this term 0.9397 by n whole square.
Mm.
So this will be 0.9397 by n whole square. From here, refractive index. Actually, we have to calculate we have to calculate IC. But if you get the value of n from here, sin IC is just 10, right? Your critical angle will be there. But this solving, this is such a big term. 0.93
Can't we approximate it into one? 0.9397.
equal to 1 only, 1 by n square. Let's do that only because this is a very big term otherwise. So 1 by n square will be 1 minus 1 by n square. Let's shift this. So 1 by n square plus 1 by n square is equal to 1. 2 by n square is equal to 1. N is equal to 1 by root 2. Almost this will be the value. Right? 2 by n square.
Yes, ma'am.
Oh, sorry, this will be equal to it. I have refractive index will be equal to almost root 2. So 1.414 is the value. So see, now we will get our value. Actually, critical angle was calculated. Sin IC was 1 by n. So
Mm.
sin IC is equal to 1 by root 2.
Mm.
IC will be almost 45 degree. Why almost? Because here we approximated the value. Almost 45.
Yes, ma'am.
Have you got this? It is actually a tough question, a very tough question, this one. Because we discussed it. If you see it from your end, from at a very first view, from a very first view, this is a very tough question. You won't know how to solve it.
Mm.
Only in the refractive index of the medium is provided. So please write this
Yes,
question
ma'am.
in detail, understanding each and every step, and even clearer that how I have written. Okay. And if
Okay,
there
ma'am.
is any difficulty with any of the thing, please let me know because it is a tough question. And after the class, please practice. That's why I want to practice few questions of ray optics, once nuclei and which was is the other chapter?
Semiconductors.
Semiconductors. Semiconductors. Okay. In the school, what is going on?
Ma'am, she's teaching nuclei.
Ray optics over.
She's going to finish it. She's in the last topic. She'll finish it on Monday or Tuesday.
Ray optics.
No, ray optics is over, ma'am.
Ray
She's
optics
teaching
is over.
nuclei.
Nuclei will also be so over so soon.
Mm. Yes, ma'am.
How is it done then? Like how can okay the topics?
Ma'am,
So
the
are you people
portions
able to
are
understand
always ready.
everything?
No, ma'am. None of the students are able to understand. We just
So why is she going so fast, Rasmi? Now I think then in your school wave optics, AC, EM waves, atoms, only these chapters will be left.
yes,
That's it.
ma'am.
So it's just September, at least first week of October. Okay, then we can't do anything. You can't also do anything. You have to follow whatever the school does. It's okay. What we can do at least is we can have extra classes here. Few classes only
Okay,
I
ma'am.
need. We don't need so many classes like before because this chapter major portion we are done with. Means this was the major portion till TIR. Now lens is a
Mm.
one good part that is left. Lens we'll do. Optical instruments are
Yes,
there,
ma'am.
telescope and all. That is one topic, and one topic is prism. So like these three major topics are there in which small topics are included. So that will be completed, but I need class for nuclei and semiconductors. Okay. Let's see. Please write it.
Can you scroll down? Can you scroll down? Can you scroll down? Can you scroll down? I'm done, ma'am.
Okay, Bhashmi, there's this question. Please try this. First write it and then try it. I'm just coming after praying Asar. Okay, it will just take me 2 to 3 minutes. This is 1.44. Okay, please write it first. I'll just come in 5 minutes. Please just text done if you get any answers. It is 1.44 if just in case you couldn't see.
Ma'am, will sine R always be 90? What?
This is not critical angle. This is angle more than critical
Ma'am,
angle.
I can't hear you.
My voice? It's unmuted. Yes, Basmi, am I audible?
No, ma'am, I can't hear you.
Now? Now?
No, ma'am.
It's still not audible. Moment. Still not. Now? Am I audible? No. Rejoin. Rejoin, Basmi.
Hello,
Yes.
ma'am?
Am I audible?
Uh, Yes, ma'am, I can hear you now.
Okay, so it means whatever I said with my camera off, you couldn't hear. And when my camera was on, then you realized I was speaking and my voice wasn't coming. And I spoke
Yes.
everything. That. What
Uh-huh.
were you saying? R and all. What were you saying?
Ma'am, will sine R always be 90 degrees?
No. Is there any critical angle here? This is total internal reflection occurring. No, optical fibers. This is one of the
Ah,
applications. So
so
see this
only when
angle.
it...
It will be greater than critical angle. Only at critical angle R is 90 degrees. See, here it says figure shows a section of light pipe made of glass fiber of refractive index 1.68. This is made of 1.68. The outer covering is made of the refractive index 1.44. This one. I was saying that if you couldn't see, this was 1.4. What is the range of angle of incidence rays with axis? Means you have to find this I. You have to find this
Yes,
I,
ma'am.
angle of incidence. This is the main angle of incidence, for which
Mm.
TIR takes place inside the pipe. So here TIR is occurring. See here, for total internal reflection to occur, the angle of incidence here, I dash I have written because if I take this also as I, then you will be confused with this main I. The actual question
Mm.
says to calculate what is the angle of incidence. It's a very topic, Basmi. Topic in the sense questions are very different and distinct questions. So I'll suggest please practice this today itself. Okay.
Okay, ma'am.
I want you to practice good questions from this chapter now. Leave EMI and whatever were left. No, EMI you did. AC and EM waves. So it says what is the angle
Mm.
of incidence means, right? So I have just taken that I dash wherever TIR is occurring no, at that point. This is one of the applications we'll discuss also. So this angle is greater than the critical angle. So it means for total internal reflection to take place, this angle has to be greater than the critical angle. I dash is greater. So this angle is, this I dash, it is greater than critical angle. Now, if we see this angle, I dash, R, and this 90 degree, can I say this I dash R plus 90 degree is equal to 180 degree?
Yes, ma'am.
I can say that. So from here, I can say I dash plus R is equal to 90 degree.
Yes, ma'am.
From here, I can say my I dash is equal to 90 minus R.
Yes, ma'am.
Okay. Now see,
Ma'am, where did you take 90 degrees from?
I have taken 90 degree this one. See, this is the triangle that is formed. This one,
Oh, yeah. Okay, ma'am.
this is hard, this is 90 degree. Okay, this will be used a lot. Almost in every question. See, that's what I'm saying. It is tough for for you right now. Once you practice, then it won't be tough because a similar pattern will be used in every question. Snell's law apply karna hai.
Mm.
And you have to apply, I mean, you have to, I was saying you have to apply Snell's law. Then you have to use the triangle for
Mm.
adding all of it as using the angle sum property, and like this calculate critical angle, sometimes the refractive index is as and all that. Okay, so this is, yeah, so I can say sine I dash is greater than sine I c. Okay, now the refractive index 1 by n. Refractive index here will be basically 1.44 c. This is the rarer medium. The rarer medium is given as 1.44. Denser medium is given as 1.68. So
Yeah.
NR by ND is equal to 1 by NDR.
Yes, ma'am.
1 by N, NDR, if I write NR, only I'm writing, that is 1.44 divided by 1.68. That is 0.86. Okay, is it?
Okay, ma'am.
1 by N is, now what is sine IC?
Okay.
I can say sine IC is equal to 1 by N. And what is 1 by N? 0.86.
Yes, ma'am.
Okay, now look, from here I can say sine IC is 1 by N. Value of sine IC critical angle is 1 by N. Look here, for this point where total internal reflection is occurring, the sine I dash, I'm focusing on sine I dash right now, okay? This sine
Okay, ma'am.
I dash is greater than the critical. Okay, one more thing. Here, let me just first complete what I was saying. Sine IC is 1 by N. So can I say sine IC is equal to 1 by N is 0.86? I can say this.
Yes, ma'am.
Now, as I discussed with you, I dash eventually came out to be 90 minus R. And we have, see,
Mm.
for TIR to occur, sine I dash has to be greater than sine IC. Means
Yes,
this sine
ma'am.
I dash has to be greater than this 0.86, greater or equal maximum than 0.86. 0.86
Yes,
from here,
ma'am.
sine IC's value. Okay. Now I dash we have got it as 90 minus R. So can I say this sine 90 minus R? Why? Why am I focusing on R? Why am I changing? How am I going? See, reason is that if I somehow get this value of R, this R, I'll be able to calculate
Mm.
psi using Snell's law.
Yeah.
So using
Yeah.
this triangle, this whole concept, see, using this whole concept, how am I going? I'm just telling you this. Why am I doing these steps? So that you can follow the similar steps. Look, one thing that was observed here, TIR was occurring. Okay, for
Mm.
TIR to occur, if this grazed over the surface, this would have been the critical angle directly. Many things would have been
Mm.
sorted there itself. Because other angle is 90 degree, this is critical angle, you know how to calculate, use it simply. Problem is that I have to calculate this angle. This is what the
Mm.
question says, calculate what is the value of this angle. To get this is air. Here refractive index is given. This R is given. Everything will be given to calculate I. So I am focusing on
Yes, ma'am.
calculating the value of r. If I get sine r, entire work is done. Now, here
Mm.
one hint the question gave that these are optical fibers, basically like your optical fibers. These are getting reflected internally, means it is TIR has occurred. If TIR has occurred, this is greater than a critical angle. Now, how it is
Mm.
changing or differing our answer? Differing is, it says what is the range of the angle. So greater than or equal to IC, whatever is greater and equal to IC, those entire range will be your answer. You
Okay,
don't
ma'am.
have to actually calculate the range from 50 degree to 30 degree like this. You don't have to calculate actually. If I say, let's say my critical angle is 30 degree. So I can say
Mm.
angle 30 degree or more. So entire range from 30 degree or more. You don't have to calculate. That is what the question is. Range part, such tough languages, that's why I mentioned. So if I calculate this angle, or anyways, I have to calculate R. So what did we do? Here we applied the TIR's condition. This angle is greater than critical angle, then only, because we cannot equate it to critical angle. This is TIR. So we have angle has to be greater than critical angle. So see, likewise, the light ray has also traveled from here to here. So using the whole concept of sine I dash greater than sine IC, IC could be calculated using NR and ND because it involves the
Yes,
refractive
ma'am.
index. So sine I dash was greater than this 0.86. Now I have to convert it somehow to this value of R. The problem is that I have to somehow calculate it to the value of R. So I have got sine, that's why I said sine I dash is greater or equal to 0.86, but that won't solve my problem. That is that inner angle of incidence. I want to focus on that major one. That is my question. So if I get R, I'll be able to calculate this. I say
Mm.
sine 90 minus R because see sine theta can be used from this. I calculated no I dash is 90 minus R using angle sum.
Yes,
It is
ma'am.
using angle sum property ASP. So sine 90
Mm.
minus R is greater than 0.86. Correct.
Yes,
So see,
ma'am.
sine 90 minus R is greater than 0.86. So sine 90 minus theta becomes cos theta. I can say
Mm.
cos R is greater than or almost equal to 0.86. Same thing. Cos R.
Yes, ma'am.
Okay. Now this sine R is equal to under root 1 minus cos R square. Means if I use this
Mm.
sine square R plus cos square R is equal to 1. If I use this identity, sine R will be under root 1 minus cos square R.
Yes, ma'am.
Okay. I can finally say the 1 minus 0.86 under that will be 0.26 when you will solve it. Okay, that's why I had pre-written the value so that we don't waste our time in calculation. So sine R is greater than or equal to 0.26. That's what I was looking for.
Mm.
If I have cos R, calculation of sine R is not difficult using this identity. 1 minus 0.86 do this under root of that term will give you around 0.26 when you solve. Now, once sine R is there, then we'll apply, let's say this is some point, n. At n, we'll apply the Snell's law. At n, we'll apply the Snell's law basically. Now, Snell's law will be, see, air's refractive index into sin I is equal to
Mm.
this refractive index into sin R. Same refractive index
Mm.
into angle. So similarly, sin I into 1 is equal to 1.68 into sin R. 1.68 because inner one is 1.68. From
Yes,
here,
ma'am.
actual sin I will be greater than or equal to 0.436 when you calculate. But please do these calculations properly again because these were done in a rush by me just so that it could save the time in the class. So please do it again properly.
Okay, ma'am.
See, this is the range. Sin I angle value means starting from 0.436. And even in fact, angle of incidence is asked, you can say it like sine inverse 0.436. All the values will be there, but please make the calculations. Did you get it?
Yes, ma'am.
Right, this question you have written, I think.
Yes, ma'am. I got the question.
Please write it from here.
Can you scroll down? Can you scroll down? Done, ma'am.
Okay, so just this line have you written? This part?
Yes, ma'am.
Have you understood the question?
Yes, ma'am.
So these were two very, very important and a little tough questions. So practice them well, practice them properly. Okay, Basmi? And I'll also make you practice good questions. So that's why let's complete the portion. See, applications, one of the applications I discussed with you in the last class, that was the mirage formation. So there are various layers of the atmosphere, and because every layer will have a slight difference in the refractive index. Understand this properly what I'm saying, and if there's any trouble or anything you want me to repeat, please tell me right now only, because these things when you write in your
Ma'am.
notes, the theoretical part you'll have to write it on your own right now only. So if there's any trouble or anything, please stop. So what happens basically, there are various layers of atmosphere, and these every layer of atmosphere has a slight different refractive index from each other. As a result of which, what happens? When the light ray enters in one of the layers, it keeps on getting refracted, and eventually total internal reflection occurs when the critical angle is crossed. If the critical angle is crossed, total internal reflection occurs. So without even any glass, any spherical mirror, any lens, there is a reflection of the object that is formed, which is known as the mirage formation. Especially in scorching heat, you may see this. It seems like water is there on a very, very deserted area. Reason is that it looks like a deserted area, but due to the reflection of the sky, it appears as if water is present. So this mirage is always used metaphorically in the English literature also, mirage formation and all. So this is what is one of the applications of it. Okay. Second, which we discussed, remember, brilliance of diamond.
Ma'am.
Light comes, total internal reflection occurs, and it keeps on track. That's why whenever we have any diamond kind of material, diamond actually, not diamond kind of material, diamond only. Because for other materials, this angle value will be different. Light gets trapped. So that's what keeps on shining. It's as if light is there trapped inside. Now, third one I wanted to discuss that time also. Third one is very important. Comes in these are questions from your board exam itself. See, reflecting light by 90 degree, a prism will do the function. This is the right angled prism. How? Let's say this is our object. Let's see, can it be reflected by 90 degree or not? See, the light rays will come. Now, at this point, these mirrors, these prism surfaces, this will get totally internally reflected like this. So this will come like this, and eventually it will go downwards like this. So see, here this was the point and this was the top part. So see, this has been deviated like this. This is AB. This becomes your AB. Can you see? Object was like this. Now it is like this, deflected by 90 degree. Yes.
Ma'am. Ma'am.
Have you understood, Masmi? Your voice didn't come actually.
Yes, ma'am. Can you hear me?
Okay. Yes, you're audible. All right. So this is what the reflection of the light rays they are there, and these questions have directly come from your board exams as well. Okay, so these are exact questions from your board exams. How the light rays and all their function. So this is 90 degree deflection. One is deflected by 180 degree. See, if on this surface, this is the right angle prism. Here, if I take the object, this is A, this is B. Light rays come. They are chosen at a point where, see, where these prisms are taken with such values of angle, so that the TIR occurs. So here also TIR will occur. Here also TIR will occur. Okay, so here when the TIR occurs, this is how the light rays are formed. Okay, and see this way too, if this is it, just a minute, Rashmi. I just have to plug my laptop. Okay, just wait.
Okay, ma'am.
Yes. Yeah, I was discussing the prism part with you. No, this is this clear? The 90 degree one.
Yes, ma'am.
Okay. See, to reflect it by 180 degree. See, it's a 90 degree prism only, right angled prism. Here, this will be 45, of course. Let's take the object here. So light rays, see, they will come at the surface like this. This will be totally internally reflected. This is the normal reaction. So see, this way it will come. A little unclear in this. I'll try to draw it better. Here also they'll get totally internally reflected. So see, this will be like this and this will be like this. So gapping is very less because Inclination has not been drawn. Please draw this properly with the help of a scale, okay?
Okay, ma'am.
See, the light rays will come. It will, right here again, normal reaction will be there, total internal reflection will occur, and the light rays. See, light rays are coming like this. They get here, TIR occurs, here TIR occurs. This gets here, then it gets reflected. And this way, so this is AB, this is AB. Okay, so see, this is 180 degree, like this is close, this is complete 180. What are these two applications are extremely important. These come a lot in the exam to draw. Specifically, 3 mark questions have come. That's why I'm telling you, okay? Then
Ma'am.
last one is optical fibers, which we discussed right now, the kind of example. What happens in optical fibers? Have you seen those optical mouses where light is there, red color, right? Yeah. So they
Yes,
actually have
ma'am.
these optical fibers. So there the light rays, they actually function due to this. It is used in computer devices and all. Mostly this
Oh,
is used in computers. So light ray gets, now see, different refractive indices are made, outer fiber and inner fiber. It keeps on getting trapped and reflected. TIR occurs at every place, so then eventually the light is shown. Got it? Got all the points?
yes, ma'am.
Write this in words as well so that you remember, but wherever you stuck while writing, let me know if you want, I can write everything also. Okay, please write.
Okay, ma'am. Can you scroll down? Ma'am, can you scroll down? Ma'am, you can show the picture. Ma'am, can you scroll down? Ma'am, can you scroll down?
What, Wesley? Are you saying something?
I'm done.
You're done?
Yes, ma'am.
So TIR complete topic is done. Now I'll start with spherical refracting surfaces and lens. So spherical refracting surfaces I'll try to cover tomorrow itself. There's a small derivation. So I'll cover it tomorrow only, okay?